Hi, everyone. And as we wind down this semester, we have talked about malware we've analyzed malware in different ways. We've looked at the how it looks statically and also dynamically, and we've also analyzed what makes up the malware in terms of how your computer processes the malware, in terms of looking at how the assembly language can reverse engineer the malware. And now we're going to look at the various behaviors, if you will, of malware. So we're going to start off with the concept of the downloaders and launchers. So in other words, what are the bad exploitations that malware can do for us, or can do to us? So one of the things that malware can do is they can cause your PC to automatically download exploitative payloads and also launch them. Okay, so a downloader downloads another piece, as it says, it downloads another piece of malware, and then, of course, when it comes to launchers, it can execute it. Okay, so these two things are very much related. Now, when a piece of malware is downloaded, it uses the Windows API or application programmable interface. It uses the Windows API URL download to file A, followed by a call to winexec. So in other words, if you were to analyze your, I'm going to say your OS processes, you would look out for the keyword URL download it to file A, and you would also look for the keyword winexec. Now, as I said before, it also does things like launching or loading pieces of malware. So it can store malware in such things as a portable executable file, or PE file. Another aspect of malware are what they call backdoors. A backdoor provides access to, or shall I say, remote access to the infected machine. And frankly, it is the most common type of malware, often communicating through the web through HTTP port 80 or 443. Okay, and of course, inexplicable, or shall I say, foreign or strange network activity are red flags, if you will, that there is a backdoor installed. Common capabilities include the ability to enumerate your display windows, creating directories, and a huge thing is manipulating your registry, because on Windows 11, unless an application is signed within your registry, it will tend to automatically presume it is a Trojan horse, or it is an exploitation, and it will shut it down. The next thing that a malware can do is what they call a reverse shell. So the infected machine, what happens is a user downloads a piece of malware, and as it says, the infected machine will call out to the exploitive machine, and it will say, "Hey, what can I will do whatever you tell me to do." Okay, that is what we call a reverse shell. So a non-reverse shell, or a default shell, is basically when we create it on our own machine. But a reverse shell is when the infected machine calls out to another machine, and actually calls out for command. So it's like it's in reverse. So the basic reverse shell is you can, in the process, it calls the create process, and it does something called manipulate the startup info structure. And you'll see the process. It will create a socket, okay, you could almost say to the server machine or the commanding machine, ties the socket to the standard input and output and error for the command executable. And the create process runs the command executable with its Windows suppressed in order to hide it. Now let's talk about remote administration tools, and it's poetically referred to as a RAT, and you're going to see it's similar to a botnet, except the difference is severity. So the remote administrative tools, you'll have one client, and that one client will have control over several servers, and you will be actually instructing each server to take up a particular action. An example, of course, is Poison Ivy. Now, a botnet is, of course, a collection of those compromised hosts. So the difference between a rat, as they say, and a botnet is just severity. So a botnet can control thousands of hosts, also called bots or zombies, and a rat is only controlling, like a handful. And you can see that it's the scalability, and because a remote administrative tool is only controlling a handful, you can manually give each of your controlled PCs, actions to do, whereas a botnet is literally, in the thousands. So you're going to send more automated information, automated stealers. So when it comes to credential stealers, there's three types. The first one is waiting for the user to log in and just steal the credentials. The other one is more automated. You dump so in other words, you run a program that it's kind of like a man-in-the-middle attack. You dump the stored data, such as password or username hashes, or usernames and password hashes. And the third way, of course, is a keylogger. An example of the credential stealing in the man-in-the-middle attack is the Gina interception. The graphical window, and this is going all the way back to Windows XP, so it's not something we have to worry about right now. But Windows XP utilizes something called graphical identification and authentication, or GINA. And it allows third parties, like through APIs, to customize the login process. And it is and what you're going to do is look for the keyword, the key DLL msgina.dll, and that is actually legitimate. Okay, that's legitimate. But what happens here is this fsgina acts as the man-in-the-middle attack almost. So Windows login will pass through fsgina.dll and then send it off to msgina.dll. And what happens is you wind up, and that's why it's kind of called an MITM, or man-in-the-middle attack. And what you want to do is take a look here, and you can see here that you're looking at the WLX logged out, and it calls msgina, which is good. But then you see this log2 file right there, and you'll see that the malware logs are credentials to system root 32 drivers tcp udp.sys. Okay, so that's where it will, where it will dump, quote unquote, the password hash. Now it is gone, as I said. It's no longer used in Windows Vista or later. and it's replaced by credential providers.